Good morning, folks. Thank you very much for showing up here. It's really great to stand up here and see all of you anxiously waiting to see what we have to offer. I hope day one was great for you. Let's get started. Today, I have three presenters. I'm Matthew John. I'm the Group Program Manager for Hyper-V and Containers. I have Sid and Ravi with me. They'll be talking about networking and storage as well. Getting started, today's agenda, we'll talk about software-defined data center that includes compute, network, and storage. We'll also talk about the offers that we have from a hardware and software perspective. But before anything, I just want to say a big thank you to all of you. I was standing by the booths. I've been talking to a bunch of you. I saw a few of my friends walk in as well. It's great to see how you have used the products that we have built in the past, Windows Server 2012 R2 and earlier. I know a bunch of you have been using Windows Server 2016 preview as well. There have been 1 million downloads and 1 million installs of that, and we learned a lot from that. You have been very vocal with your feedback, and we have taken that, and we have used that to keep improving our product. And as we keep looking beyond 2016, we consider those feedback and make sure that we keep improving it so that we build the best product that you guys need and can use. So thank you very much. Let me start the whole history with a very brief talk about how the evolution happened. We are talking about virtualization. We shipped the first product in Windows Server 2008 R2. We're just making the initial steps into virtualization, but very rapidly caught on, essentially simplifying the whole virtualization layer, making it just a commodity like anything else. But then the whole industry evolved from there. They called it dynamic data center, and after that, we started having the makings of the cloud, and here we are with Windows Server 2016, talking about what does it mean to have a virtualization platform that is building the next generation, the cloud. And so that's the evolution. It's all about cloud infrastructure, cloud applications, how do you bring the cloud on-prem, and so on. So that's where we started off from. And when we started looking at Windows Server 2016 as part of the planning exercise, we were looking at what were the trends that were going on in the industry? What was changing? And the one thing that kept coming back to us was people stopped thinking about servers and they started thinking of services. And the big difference between the two was the way people start writing applications. Now, sure, there's been cloud-born applications for quite a while, but it wasn't mainstream. We started noticing some of the industry trends around those things. We also started noticing that from a hardware perspective, people were expecting more standardized, cheaper hardware and more intelligence in the software. So standardization of processes, standardization of tools, a service-focused industry was being formed. Then we went and started talking to you guys, trying to figure out what is it that's top of your mind. And very clearly, we could come up with three distinct things. A, from a security perspective, you've probably heard multiple speakers yesterday talk about security. The way I think of security is if, as an individual, you start understanding that the first advice a financial advisor gives you when you start thinking about future and retirement and any kind of assets that you're building is A, protect your assets. When you apply that to enterprises, it's the same notion that comes in. Security is all about protecting what you have. The attacks that's getting more sophisticated are coming from all sorts. There's attacks originating inside, so even the kernel is not considered a completely secure environment. When you couple that with cloud and virtualization, you figure out that the virtualization administrator is God. They can do anything they want with the virtual machine, regardless of what kind of encryption you have inside the virtual machine. How do you protect against that and make sure that you have a comfortable and a solid story there? So that's security. You start looking at the application space and you see a new breed of applications that's being built, a new breed of mentality of DevOps being created at the application platform thing. And then the core infrastructure, people want more. They want a simplified environment, something that scales up, something that starts from a single node, two node environments to large hyperscale clouds like Azure. And essentially, you just want more of everything. And so we took that feedback and we started with this, the security thing. We built multiple solutions, and that's what we call by a multi-layered approach. We had solutions like JIT, or just-in-time administration, and just-enough administration to prevent attacks from happening. But we didn't stop there. We assumed that an attack would happen, and we said, assume that the kernel is compromised. How do I still keep my secrets? So we introduced capabilities like Device Guard and Credential Guard. That's part of Windows 10 and Windows Server 2016. But that's not enough. How do I protect my VM from potential malicious administrations? That's why we introduced Shielded VM. And you can learn all about that in the session for Exploring Windows Server 2016 Security. We then looked at cloud-ready applications, the platform. We thought about what is the smallest runtime possible that is single purpose, and how can we provide that kind of a runtime environment that allows you to have just enough operating system. And that's when we built Nano Server. We added containers, native container support. We added what Linux had, which is a shared kernel model. We also went beyond that and provided Hyper-V containers that provides tight isolation across these containers, so we could contain the breach boundary if at all any of those container runtimes try to maliciously attack the host. You can learn all about that in Explore Windows Server 2016 application platform, and there are many more sessions on containers. But today we are going to talk about what does it mean to build an infrastructure. The infrastructure that scales from a single node, two node hyper-converged environment all the way to Azure. That's a super hyperscale public cloud, and that's all powered by the same Windows Server 2016, same Hyper-V. So with that, let me present to you Windows Server 2016. Not a big surprise, you have heard this for a while. But the main thing over here is that this is the operating system that powers our businesses, that powers Azure, and we hope that will continue to power your businesses going forward. And let me call out to System Center. While we built our Windows Server 2016, the System Center team has been hard at work trying to build a management suite that manages your on-prem deployment. You can hear more about that in the session. Take advantage of new capabilities in System Center. That's, I think, happening in parallel right now. So switching gears, let me go over to compute. So this is one of the three pillars: compute, storage, and networking. So compute, it's all about Hyper-V. And we start by saying you can virtualize anything with Hyper-V. We have been saying that for a while, and we keep pushing the boundaries. Now, it's good to be here and be the representative of Hyper-V and talk about what we are building. But it's interesting and good for me to know that I'm building on a legacy that's already existing. So with Windows Server 2012 R2, we had tons of innovation. We had tons of capabilities and features we introduced. It was our attempt to say that let's even the playing field. Let's make sure that virtualization as a platform was no longer the place where we had to compete, where you as our customers do not have to walk around with a notepad trying to figure out feature parity or feature comparisons between different virtualization vendors. So in 2012 R2, we decided we will go beyond what was available at that time. And the things that's bolted out, like 64 VP monster VMs, 1 terabyte monster VMs, or the 64 terabyte VHDX, or the Generation 2 virtual machine that we built ground up as a virtual machine, not as an emulator of hardware. So all of these things at that time were innovative. But we never expected it to remain innovative for long. We expected our competition to catch up and ensure that you get the best benefit from having a diverse virtualization platform. So that's what we started off from. And then we said, what else? What do customers need from a compute perspective? And they talked about, I want more performance. I want more reliability. From a reliability perspective, it's all about my hardware. I'm just going to use standard hardware, which means that the hardware can go down. Please ensure that your software can take care of this unreliable hardware. We talked about security, but that was a very clear ask from us. I want improved security, and security from a very different lens from what we have always heard about. And clearly, the flexibility to grow, shrink, the flexibility from resource handling and management, flexibility of different kinds of hardware from storage or networking, and so I want all of those. So we took Windows Server 2012 R2 Hyper-V, and all we did was we added a ton more features. And that is what we keep doing. We keep pushing the boundary. We keep adding it. Now, you might argue that this is a pretty saturated environment. What can you do in Hyper-V? What else can you add? And well, we kept adding. So we have new things like shielded virtual machines that no one else has. Virtual TPMs. We have 240 VPs, 12 terabyte beast VMs. Time sync improvements. We introduced nested virtualization as a production-ready feature, and many more. And you can hear all of this later in Ben-Am's session, and there are a bunch of other sessions where you can talk about specific features in detail. Now, let me pick a couple of key scenarios or key features out here, and not dwell too many on each of these individual features, just in the interest of time. So the one thing that I want to start off with is Nano Server. Now, you heard me talk about Nano Server from an application platform operating system point of view. But Nano Server actually has the same duality that Windows Server actually has. There's Windows Server for the fabric and the infrastructure, and Windows Server for the app plat. Nano Server follows that pattern. So there's Nano Server for your application platform, which is the super small, lightweight operating system on which to run your IIS or Node.js applications. And then there is the Nano Server on which you can build your fabric, your next generation of fabric. Microsoft is committed to ensuring that we provide the best experience for you. We called it the just enough operating system because we felt that there's no longer a need to build monolithic operating systems, that what you need is what you can build. So we split up the operating system and we give you the components so you can put together what you need. If it's a Hyper-V environment or if it's a file server environment. So we have essentially reimagined what server operating system should be. So that's the reason why it's very familiar, but at the same time it's different in that we are going to break a bunch of notions that most of you are familiar with, which is the UI is the predominant way of managing. The local UI is the predominant way of managing a server. We said, you don't need that, especially in the cloud era where there are hundreds and thousands of these machines around. You don't want to be logging into each machine and managing it. So we took that away and we gave you remote management. Now there's tons more that you can learn about it. There are roughly about 4 to 5 Nano Server sessions where you can understand more about what Nano Server is from a configuration and from a remote management capabilities. Please make sure you attend each of those, or we are at our booths at the expo hall. Come by, talk to us. It would be awesome to keep talking to you about what we have built with Nano Server. Switching gears, for the tons of innovation that we have added to our platform, we wanted to make sure that there was a very simple, frictionless way for you to take advantage of it. And that's the reason why we kept investing in ensuring that your workloads can carry forward with zero downtime as you upgrade from a 2012 R2 infrastructure over to a 2016 infrastructure. We call it the frictionless upgrade. Essentially what it means is you have an existing cluster. We now support mixed mode clusters. So you can initially start off with a 2012 cluster and individually upgrade your nodes to 2016. You can add both of those. You can live migrate the virtual machines back and forth, and you can upgrade all the machines in the cluster to 2016, and then with a giant switch, just turn on the clustering capabilities of 2016 by saying now the cluster is ready for 2016. So step by step, you can move one VM at a time or your entire cluster over to 2016 with zero downtime to your workloads. Moving on, let me talk about the Hyper-V scale limits that we have announced. You heard this yesterday. We can support from a host perspective up to 24 terabytes on the physical server. That's 6x more than what we had with 2012 R2. We can have 512 logical processes for on your physical machine. That's up from 320 that we had, and up to 12 terabytes and 240 virtual processors, I take it back, inside my virtual machine. So let me show you something that no one has seen prior to today. A quick demo of this Beast VM. Now, before I go in there, the Beast VM is actually not going to be a 240 virtual processor, 12 terabyte VM. I could not get hold of one for this particular demo, but it has 128 procs, 5.5 terabytes, and it's running SQL Server. It's an HP ProLiant DL580 Gen 9 series machine. So with that, let's see. This is going to be a very short demo where the first screen that you're seeing there is my task manager inside my Beast VM. It has 128 processors. It's fully loaded. It's just running like crazy. That's because I am driving it. It has SQL Server installed on it. And there's on my left side, I'll show it to you in a sec, there's a client VM, or client machine that's driving an OLTP workload on it and maxing it out. There's a 4 terabyte in-memory database inside this virtual machine, and it's chugging along quite well. What you notice here is it has 5.5 gigabytes of RAM, 5.5 terabytes of RAM, and 128 VPs. And on my left side, and this is the amazing thing, what you see there in green, the 322K, 320 odd K, that's the number of transactions per second that it's driving. And that's at a latency of 20 milliseconds. No one has seen this before in a VM. Yeah, thank you. This is huge. Yes. So very quickly, let me switch over and show you a few more things. So I have another demo called the virtual machine start ordering. This is one of the capabilities that were added to Windows Server 2016. And what we are seeing here, and this is just a video, is that I have 3 virtual machines that I've created into groups. I have a DC group with the DC VM and 2 application or workload VMs that's dependent on the DC VM. So the first step that I'm doing is creating those groups. And the second thing that you just saw was I've just added a dependency saying that the workload VMs should not start until the DC VM has started. So essentially, that's what we are doing. I'm setting up the dependency, and you see that over there. So I can create groups of virtual machines and set up dependencies. Now I go to my cluster manager and simply say start all the VMs, and the VM ordering will automatically click in, and it will have a simple way of ensuring that the VM that you had a dependency on starts up first, in this case, the domain controller VM, and then the workload VMs will start following that. Again, this was just one of the many features that we have added into Windows Server 2016. Let me switch back to the slides. So wrapping up my compute section, I just want to call out what I started off with everything, which is when we talked about Windows Server 2016 from a compute perspective and talking to customers about what they want, they said they want more. They want more of many things: performance, reliability, security, flexibility. And we believe we have delivered that. We have delivered more of everything and even more of that. But having said that, we're definitely willing to listen to you. We have been listening to you, and we continue to listen to you in terms of what else can be done to keep moving the ball forward. What else can be done to ensure that you have the best environment you can build for your organization. So with that, let me hand off to Ravi. Thank you.
Thank you, Matthew. Good morning. My name is Ravi Rao. I help lead the data center networking efforts alongside a group of very smart engineers and program managers And today I'm going to talk about the immense customer value and innovation that we're bringing in the Windows Server 2016. So, data center networks have become pretty complex over the years, the physical networks. In our own Azure environment, we've gone through multiple generations of evolution of our physical networks. And what we've found is that application deployment in such environments takes time. Because in the traditional model, if you have an application, that application or workload will typically have a number of networking policies that have to get modeled on the underlying physical network. You might have switching policies, routing policies, you might have load balancing, firewall, and so on and so forth. And the challenge when you're deploying the workload is the process of deploying onto this physical network requires change orders and trouble tickets. And it's fundamentally somewhat error-prone and time-consuming. And it's time that we just didn't have in our own environments. When I talk with customers, I hear this quite a bit as well. I mean, customers frequently come and tell us that, you know, the CIO is holding me, IT, responsible for my developers not being happy because they're not able to onboard their applications as quickly. For the proliferation of shadow IT, and a lack of DevOps in the environment, again, because things are too slow, and in general for the organization just not being as competitive as they'd like to be. So there is a strong need to increase agility, and networking tends to get in the way. The second problem is around security, that you want to be able to deploy your workloads in a secure manner, and if attacks, or rather when attacks occur, you want to be able to contain them from a network perspective, quarantine it from a network perspective as quickly as possible so that these attacks don't get a chance to spread on the network itself and wreak havoc. And the third thing, while you're having to execute on agility and security, is that there is a need to constrain costs because your CXOs are basically still looking at IT, or that's what customers tell us, as a cost center. And so you still end up running on constrained budgets. And so there is a need to increase agility, enhance security, and do all of this while keeping costs down as well. So we've been working over the release with many Windows Server customers on deployments. And here is what one of our customers had to say, that they were able to bring up the SDN fabric and deploy applications fast while being able to drop down cost at the same time. And I hope all of you are able to start pilots and do deployments that let you reap these similar benefits as well. So the question is, how do we do it? So what we do in the Microsoft Azure environment is we build an SDN fabric on top of the existing physical network infrastructure layer. Okay, so this is a fabric layer that's on top of the existing physical infrastructure layer. And this fabric is one that you as IT have complete control over. So when an app or a workload comes in and says, I have a set of policies that have to get deployed onto the network, those policies now only have to get deployed on this fabric that is layered on top of the physical network, as opposed to needing to get modeled on the physical network itself. Now, this fabric is entirely based on, is entirely on the hosts itself. So if you think about what all this fabric exposes, it exposes all the standard things you'd think of. You know, it has switching, it has routing, isolation, load balancing, firewalling, edge policies, so on and so forth. And all of this is modeled in software running on the same hosts that your compute VMs are running on. And what pushes the policy down is a network controller. So to take a concrete example, let's say you have, a tenant that wants to push down a policy saying, I only want to open port 80 on my web server VMs, right? There shouldn't be a need to open anything else. Well, what happens is the policy comes to the network controller, and the network controller now finds the hosts that actually have those particular VMs running and pushes the policy down to those to those hosts so that policy enforcement can happen at the source. So you don't need policy enforcement moving into the network where it occurs. Right at the source where the policy has to get enforced, it gets enforced there, and the right things happen at that point. So similarly, we have an all-new software load balancer that is available just in software, running on one of your hosts. It's an L4 load balancer that supports a wide range of capabilities. And we have gateways and firewalling policies and so on and so forth. So it's a rich SDN fabric that supports the needs of the application you're trying to deploy. And there are a number of ways in which that can be provisioned. System Center Virtual Machine Manager can be used for effectively setting up the SDN fabric itself and then configuring any tenant policies that are necessary on top of that. Microsoft Azure Stack, that I'm sure you've heard of in many talks by now, uses the network controller for provisioning such policies as well. We have PowerShell automation available and a REST API for the network controller as well, such that if you want, you can build your own RESTful apps for doing such configuration. So in short, if you're an IT admin, you will have complete control and automation capabilities on this SDN layer because it is insulated from the changes that are happening in the underlying physical layer. When a workload owner comes and says, deploy my app, you know you can deploy it quickly because the set of capabilities, networking capabilities that the workload depends on are completely under your control as opposed to usually not being that the case. So this results in significant agility. But so if I look at it pictorially, a developer would typically come to you and say, well, here are my VMs, deploy them. I have a workload that has 2 web server VMs, 2 scale-out file servers, and an Active Directory, for instance, that I might be using. And then they'll say, yes, they need to be connected in some way, shape, or form. Now, the normal model would be you have to now work with various silos that might exist in your organization to get the policies deployed. But with the network controller-based SDN model that we use in Azure, we can do this much more quickly. I can effectively create subnets associated with each tier. I can wrap all these subnets within a virtual network using VXLAN overlays so that there is no ability for another application to peek into this particular application that I'm trying to deploy. I can deploy external connectivity for those VMs. So I can say that my web server should be able to go and speak to the internet because they have to go and get some information from there. I can deploy load balancing policies, not just external load balancing policies coming outside in. A request comes into a load balancer, which then load balances across to the multiple VMs, but internal to the app as well. So if I have multiple tiers, as you see here, then I can have one tier use load balancing into the other tier as well, so within the app also. And finally, I can connect these all up, and you're done. So it's much, much simpler for you to be able to do something like this in the model that we have. But it doesn't stop here, because it's very nice that these web servers can all talk to each other and they can talk to the file server. But as a security architect, now you come in and say, well, I don't want that. I do not want to allow all these ports open on my web servers. I have to constrain it. I have to restrict what is allowed and what isn't allowed. And so you can deploy now what we call network security groups. These exist in Azure today, and we are bringing them and making them available to you in Windows Server 2016. In the network security group, you can say something like, well, I'm only allowing port 80 in, which means RDP is blocked, file is blocked, all other port access is blocked automatically. Any new VM that's instantiated into that security group automatically inherits all this policy, automatically. It also means that if one web server were to get infected or compromised because, let's say, it was unpatched, it will have no ability to go over the network and attack the other web server, which means that your service does not go down. Okay, so one gets infected, it's compromised, might happen, no ability to travel over the network because the policy is not there. Say you want to change the policy. You want to now allow port 443 in as well. Easy. Change the network security group, all the VMs automatically inherit that policy. So it's very, very powerful for you to express what your security requirements are. Even better, you may have, your favorite virtual appliances. You may say that, Active Directory that I have is the holder of all my secrets, and I really want to guard it with my favorite firewall appliance. There are all kinds of virtual appliances you can use. You may have your favorite third-party load balancing appliance, or WAN acceleration, or a firewall appliance. You have dynamically injected this appliance in path between two layers of your workload. Imagine how hard this would be to do on a physical network. Imagine how much time something like this would take. Here, you're being able to do it completely automatically. So as a security architect, you will be able to very precisely model what your security requirements are and realize them within the app and the network. And you will be able to rapidly respond to changes. You can quarantine traffic out if necessary, because it's all software. You can easily move things around as you see necessary based on evolving threats. So let's see this in action. So I showed you in the beginning that there were two web server VMs. I'm going to go into one of the web servers. I'm going to try pinging one web server to the other, right? And you notice that it's going to fail because there is no connectivity. I try establishing outbound connectivity from the web server. That fails as well, right? Because there is no connectivity established. You just have a bunch of VMs. So now we're going to use the network controller to create a virtual network. Okay, just an object. I'm creating a virtual network. I'm now going to attach web server VMs to it in a subnet. I'm going to attach my file server VMs to it in another subnet, Active Directory. I'm going to configure outbound policy for network address translation so that my web server can actually go outbound. And I'm going to configure load balancing policies, both external and internal. Okay? All of this is done in 43 seconds, or 48 seconds. Very, very fast. Imagine having to do that on a normal network. If I try to go inbound now from outside, you notice I'm able to access the service, which is my colleague's networking blog. I have internal connectivity in the network, and I have a unique page to show that the load balancer works. I come in through the load balancer, one VM is blue, one VM is green. So you can see that the load balancing is working, and I have internal connectivity amongst the web servers. They are being able to ping each other, and everything just works, right? So the takeaway you should have from this is that you just deployed that. It started off looking like a really simple workload, but that's what you just deployed in about the time it would have taken Michael Phelps to do his 100-meter freestyle. Okay? That's how fast you just deployed something that's actually as complex as that. It's not normal. I mean, this is really cool. Now, like we said earlier, your security architect then comes in and says, well, no, the web servers are pinging each other. We have to stop that. So now the security architect comes in and says, okay, we need to go out and create network security groups. This is all RESTful API and PowerShell that exposed from the network controller. They create the network security groups, and they state a certain set of policies associated with them. And they say that this particular subnet that I have needs to be associated with a certain policy. And then they just deploy that policy. They then also go and say that I'm going to inject a virtual appliance. If you remember the picture, there's a virtual appliance that sits before AD. They inject that virtual appliance in path, and you're done. That's a picture of the virtual appliance, which is going to absorb, swallow up all traffic, all ping traffic that's going to my domain controller. If I'm trying to ping my domain controller, I'll simply not be able to, because the virtual appliance will say you have no need to go out and do it, but I will let you have DNS name resolutions go with it. So you have the ability to get fairly granular. So if you look at that picture, now that's what you have deployed. That was 28 seconds in which you deployed, or the time, I don't know, Usain Bolt would do 200 meters running on 1 foot. Okay, so that's how fast You've deployed a workload that is that complex. It looks so simple to start with. And your developers wonder, why is it taking so much time for me to deploy this? Because it's actually that complicated. And when you have the power of the SDN fabric together with the network controller and use the models we use in Azure, you will be able to deploy this fast. Because in Azure, where we are onboarding hundreds of thousands of tenants per month, and so we don't have the luxury of going and doing things in a manual way, and we want to bring all that power to you. So now the question that comes up is, okay, you've deployed the workload, that's great. What is the most important thing customers will care about once a workload is deployed? It's availability, right? You want that workload to remain available. You don't want it to go down for any reason. It's secured, it's connected, the right things, it's exactly in the way, shape, and form I want it to be. I've modeled it, you want it to be available. So now let's say I have my web servers and I start taking them down. Because in Azure, we've realized infrastructure goes down once in a while. And when infrastructure goes down, you want to make sure your service stays up, even if the infrastructure is going down. So remember this picture. I'm going to take the web server down. I'm going to take the load balancers down as well. So imagine there are two load balancers that are sitting in front of the web servers. I'm going to take those down also, and we'll see what happens. So what you see in the picture here are the two web servers, the network charts basically associated with it. I'm going to open a page, and you'll see that it's flashing blue and green, basically saying it's going to one web server and the other. And the spikes that you see there represent probes. We are probing to make sure that the web server is available. Okay, so it just keeps checking. I'm going to crank up the load, and when I crank up the load, you notice that both the web servers start, effectively load balancing correctly. So the load balancer is doing its job. But what happens if the web server goes down? If the web server goes down, our probe to the web server is going to fail. The load balancer is doing a probe. The probe is going to fail. The moment the probe fails, the other web server is just going to pick up and transparently take over. You notice the service has not gone down. It's just that the other web server is having to work harder. And after a while, it might have been a transient failure. We bring back, or the web server reboots, or something happens. The other web server that was down comes back up, and we probe it for a while to make sure, hey, are you really up, or are you kind of in a transient state? And once we're convinced that it's up, then it's automatically going to start balancing its load all over again. The load balancer will again start distributing it to it, saying, yep, you look healthy, I'm going to start balancing to you again. So effectively, a web server can go down, nothing happens to the service. But what if the load balancer were to go down? Right now, I have a load balancer that's balancing across. I have two load balancers now. What you see in the picture are two load balancers, and send and receive bytes on each one of them. Right? Both of them are doing the load balancing. Requests are coming in, they come to the load balancers, they distribute it out to the VMs, and it's good. One load balancer goes down, the other one picks up. And going a little deeper technically for a minute, the reason that happens is because we advertise the public IPs using BGP to the physical switches. So this is the interplay between the SDN fabric and the physical layer. We advertise using BGP, and then the switch does ECMP, or equal cost multipathing, down to the underlying load balancers. The load balancer comes up, the switch we advertise, switch recognizes, and it dynamically starts distributing it all again. So a web server failed, no problem. A load balancer failed, no problem. We are able to dynamically recover. But what if the network controller were to go down? The brain of the network, the air traffic controller, the plane's going to still keep flying. So now I'm just going to go and take down the network controller itself, and as you'd expect, my ping is of course going to start failing because the network controller is down. But you'll notice nothing else much has changed. The load balancers are doing what they're doing. My service is up. You can, in the background, see the green and the blue page, the web page basically there. So my service is still up, and nothing has really happened. And the reason that's the case is because we separate out the control plane, which is a SDN philosophy, basically. We separate out the control plane from the data plane. So requests that are coming in on the data plane, where a client is making a request, it comes into the load balancer picks a web server, the web server now uses load balancing to pick a file server, there's Active Directory being used. All of this is in the data path. There's no network controller in path at all. So the network controller can also go down and your service is still going to stay up, and after a short time we'll bring it back up and all is good. So effectively, you have the ability to become extremely resilient. You're resilient to your web servers going down, to the load balancers going down, to gateways going down, to the network controller going down, and your service still stays up. So as a CXO, another thing that we do actually, so resiliency, what does resiliency give you? Resiliency basically is going to save you operational expenses, right? Because you don't have to deal with, hey, my service is down, I have to answer a call, so on and so forth. But we are also going to save you CapEx. The idea here being that in the Windows Server 2012 timeframe, I had to use separate physical networks for RDMA storage and compute networking, the separate physical networks. Now, as we go from 1 gig to 10 gig to 25, 50, 40 gig to 100 gig, it doesn't really make a whole lot of sense to have 4 ports for 400 gig of capacity across networking and storage. Well, maybe in Azure it does, but for most customers it does not. And so what we're doing is we're taking the 2 separate physical networking models we've had and we are converging them in the 2016 timeframe. So in Windows Server 2016, you will be able to converge storage and networking such that RDMA storage and networking traffic flows over the same underlying NIC ports, while being able to carve out bandwidth across storage and networking so that they don't stomp on each other. If networking traffic is not much and storage is dominating, it will be able to use more capacity. If networking traffic is a lot and storage is not, networking traffic will be able to use more capacity. But if both of them are actually going full throttle, they will both be guaranteed the minimum. And then within your compute VMs, you can again do granular quality of service policies if you so choose to as well. So we give you the ability to converge down on the number of ports you need to have. So as a CXO, you will reduce costs because of increased resiliency for your actual services, the converged performance that we're bringing to you, and all these cloud-optimized appliances, load balancing and gateways and firewalling and the network controller, all of this is just included as part of Windows Server 2016. Okay. So to close out, I talked about the benefits here of SDN. I could have talked about SDN in the classical terms of, hey, there's the management plane and the control plane and the data plane. Forget about all that, because it's just that's interesting from a technical perspective, but the value it brings to you is what you should look at, which is you can deploy your workloads much, much faster. And there's a number of capabilities we have underneath the covers for that, which build out the SDN fabric layer. If you want to see in action how to bring up this SDN fabric from 0, where you have nothing, to the SDN fabric layer is brought up, Jason Messer today, I think it's at 10 o'clock or something, 10:45, is going to show you going from 0 to SDN in 60 minutes. He's going to bring up the entire fabric, and this is not a toy deployment he'll do. It'll be a fairly realistic deployment he'll do, going from 0 to 60. You will enhance your security posture. Okay, so you will be able to exactly model. You'll not be held hostage to what the physical network allows. You can exactly model how you want security to be, and then deploy it on the network, and then change it rapidly anytime you have a need to change. To learn more about how you can dynamically segment the network to meet your security needs, if you care about security, you should attend this session by Greg Costanza on Thursday. And finally, if you want to reduce costs and increase perf, if you want to see the beast mode equivalent of what Matthew showed you with VMs, 5.5 terabytes of RAM, if you want to see what the networking equivalent of that is, you should attend this session by Don Stanwyck and also learn about troubleshooting techniques with System Center Operations Manager and so on and so forth. That's on Friday. With that, I hope this was informative, and I'm going to hand it over to Sid, who will talk about some of the breakthroughs we're doing in storage next.
Thanks,
Thank you.
Ravi. Thank you. First of all, I think we are all extremely privileged to have 2,000 of our closest friends here, and we are really humbled you chose your time to attend this session. So hope you're liking it so far. So my name is Sid Roy, and I manage the high availability and storage teams at Microsoft. I work very closely with Matthew, Ravi, and a bunch of others in kind of orchestrating, also understanding the SDDC strategy. So let's delve into storage a bit. So again, in the same vein of what we heard from customers, just to give you a quick background, we started the journey on storage, software-defined storage, back in 2009, when we thought about, hey, how can we lower the cost of storage, right? And we heard about customers, that storage is not very flexible. It is not agile. I have to buy storage in monolithic chunks, okay? Even if I need a small capacity, I need to buy a complete new array. I don't have easy scale out, okay? There is no way for me to add capacity on demand. So if my storage is running out of capacity, I need a pay-as-you-grow model, okay, in a just-in-time world. And lastly, storage is very, very expensive. As we all know, in the data center, storage is around 50% of the cost. So we focused on these 4 or 5 fundamental problems and looked at storage. So before we go into software-defined storage, let's give a brief evolution. How did we get here? Okay, circa 2009, okay, when we looked at storage, let's first look at a traditional storage array, okay? This is something, SANs work great. You have SANs and NAS in the environment. Just for the broader audience, what is basically a data center with SAN, okay? So you have your compute clusters, which is our good old Hyper-V clusters running virtual machines. And that's connected through a fiber channel or I2C SAN network to a SAN array. Let's double-click on that black box of the SAN array and see what's inside that array, okay? So that array typically has maybe 2 or more storage controllers, depending on the mid-range or high-end SAN. And those storage controllers are typically PCs running a processor. It basically could be x86 or something else. It has sophisticated caching, tiering capabilities. And that storage controller sitting behind that is the backplane. And hanging off the backplane is a bunch of drives, right? Could be in one rack or multiple racks. When we looked at that, now fast forward to 2012, R2. When we introduced the concept of storage spaces, what we really did was take those storage controllers in the SAN and replace that with the scale-out file server node. So what we have done is really, taken the storage controller out and said, hey, you can deploy a scale-out file server, 1 to 8 or more, depending on how fast and how much of scale-out you need. And sitting behind the scale-out file server in the 2012 R2 wave is basically, a bunch of disks hanging off a shared SAS fabric, what we call a shared JBOD fabric, okay? So that was the world in 2012 R2. And we did 2 fundamental things in terms of cost reductions. One was we lowered the cost of the SAN fabric by going to a SMB3 storage network, while not losing all the capabilities, right? In the SAN world, if you're familiar, it has multipathing. It has low latency of CPU cycles per byte with fiber channel. We had SMB multi-channel, SMB direct, a bunch of things there. So we were very cognizant to not lose the value of a high-end SAN, yet deliver it at a fraction of the cost. Now let's fast forward to 2016. So what we have done in 2016 is really, if you see the back-end SAS fabric, we have taken that SAS fabric out of the picture. What does that mean? Okay, great, you did that. So how does it help you? The SAS fabric, basically, SAS is limited in connectivity. It's kind of limited, it goes to around 4 nodes. So what we have done is you don't need a shared SAS fabric in the back end. You can utilize the storage within the servers themselves, what we call shared nothing storage. So what you're seeing here is really a bunch of regular servers. We are utilizing the storage, pooling it together, and presenting it to the SMB3 storage network, which is presenting it in turn to the compute cluster. Okay? So very, very simple. And again, we have, by eliminating the SAS in the back end, we have reduced cost further. Now, that's not all. This is what we call the converged or disaggregated mode of deployment. That's not all. For some deployments, especially in the mid-market or smaller enterprises, why not collapse these two together, right? So what we have done is really gone one step further with this notion of what we call hyperconverged, where we basically collapse the compute layer and the storage layer together into the same machine. So your machine is really hosting the VMs and hosting the capacity and the VHD behind the VMs, all in the same physical node. So the advantage of this hyperconverged architecture is it's obviously lower cost. You can lay out more nodes as you need more capacity, compute or storage, okay? So with that, let's double click a little bit more. Before we do that, just one quick shout out. Now, once you have these storage spaces direct clusters, you can deploy 2 of these in 2 parts of the world and use another feature we are going to introduce in 16 called storage replica, and you can do synchronous replication between the 2. So all in all, what we have just shown you is you can basically deploy software-defined storage site A, software-defined storage site B, do low-cost DR, all with the software coming in the box inside Windows Server, Datacenter. So let's double-click a little bit of hyperconverged, right? Hyperconverged is a big trend in the industry. A lot of our friends are doing it as well. So let's just give it a double-click and see what's going on under the covers. So again, Storage Spaces Direct is the flagship feature of our SDS platform. What you're seeing here is, again, a recap on how you have 2 nodes, 3 nodes basically here. These 3 nodes are combining the disks together. You can carve out a CSV file system from them, 1 or more, and on that, you are hosting VMs, all in 3 physical nodes, all together. And one of the things we have done is we have unlocked performance. This can take advantage of the latest media, like NVMEs, and we're going to go further with storage class memory, which is going to be a paradigm shift. This has fault tolerance. It can tolerate failure of any node. And when you lay out the disks, we have something what we call chassis and rack fault tolerance and rack awareness. So when we place the data, we can tolerate chassis failures or complete rack failures, okay? So we have the intelligence behind the software to be able to do that. Efficiency is something we have done and improved a lot further with our high efficient erasure coding, something we collaborated with Microsoft Research on. So you get a lot of the benefits. And obviously, the cost, as I said, is included in software-defined data center. Klaus Jorgensen and Cosmos will be giving a talk on this. So if you're interested in Storage Spaces Direct, definitely recommend you attend that session. So with that, let me just do a quick demo under the covers and show you what this means, right? I'm going to show you things in PowerShell. But again, as Matthew mentioned at the beginning of the talk and Ravi emphasized, again, this is all manageable by System Center, okay? I'm just showing you things under the hood so you get a sense of what's going on. And then let's have some fun. So let's begin with 3 industry standard servers, okay? Now, they have disks inside them. Each of these servers has some disks. There is no fancy cables between the servers, no shared SAS, no expensive InfiniBand. It's just regular good old Ethernet, okay? Now let's see what's going on. So just basically showing you under the covers, what we are doing is we are showing you what's inside each of one of those nodes. One of those nodes has 4 drives and 2 NVMe SSDs. Great. Now, let's cluster them together, okay? So what we are effectively doing now is making sure that we are creating a new cluster. You can see the PowerShell commandlet there. And we're creating a new cluster called demo. And this is all happening. It's very simple, single commandlet. And then once you create the cluster, just to make sure I'm not lying about it, it gets cluster node, shows you 3 physical nodes in the cluster. It's all up and running. Okay? Once we have created the cluster, the next thing is let's create a software-defined pool of storage. So remember, each of the nodes has 4 drives and 2 NVMe SSDs, 6. I'm going to take 6 of those devices in each node, the 18 devices, and combine them all together. So this is, I'm enabling storage spaces direct. Okay? Once I do that, you can see under the covers what's going on. Basically, it's setting the right resiliency level, be that parity or mirror, and then it's basically carving out the pool properly. It's doing everything underneath the covers. Now, once I create that, you see it gets the storage pool. As I said, you get to see 18 devices underneath, okay? All goodness. Once I do this, I can now basically create volumes from those pools of storage. So let's do that. So I'm going to create 5 CSV-FS volumes. So CSV-FS, as you know, is our cluster-wide file system. And that's the distributed file system. Sitting underneath that is resilient file system, REFS, which gives you the resiliency, and along with Spaces Direct, it gives you the best-in-class fault tolerance. And REFS and Spaces Direct, they're aware of each other. So I basically created 5 CSV-FS volumes. Now, you could expose the volumes locally if you're hyperconverged, or you could expose the volumes remotely if you're disaggregated or converged through SMB, okay? So I've done this now, great. I have my 3 nodes working fine for quite a while. 6 months down the road, I start running out of capacity, okay? So at this time, I talked about, in some situations, you would need to do a procurement, get another storage device, figure out how to migrate stuff. You would need to do all that. Spaces Direct, was something we really focused on. Scale out is really simple and easy. So let's take a quick look. So I have this 4th node. I have 3 nodes. I buy this 4th node. And now I'm going to basically add that to the cluster. So let's see what happens under the covers. I'm adding the cluster node. And then I do get cluster node. Now it should show me 4 nodes, okay? So I had 3 nodes, now I added the 4th node to the cluster. And then when I do a get physical disk for that 4th node, it shows me 4 drives and 2 NVMEs. All goodness. Now, once I do that, and I didn't show you there, in the previous slide, you could see that those 4, that 4th node, the drives within that, they can join the pool. And I should emphasize the extension of the storage pool, the recreation, the rebalancing, adding the nodes to this, that's all automatic. It's really going on under the covers where your storage pool is expanding. It is laying out the data, relaying out the data, rebalancing according to the nodes, according to your rack-aware or chassis-aware policies, and doing that all in software. All pretty cool. And just to show you, once I've added this, now I don't have 18 devices. I've got 6 more devices, 24 devices new in the system, okay? So that's all pretty cool. So again, to recap, Storage Spaces Direct gives you a lot of flexibility, a lot of value in being able to add capacity when you want it. And again, this was all under 15 seconds of real time, okay? So pretty cool again. So switching gears a bit, one of the things we heard from customers, I showed you 3 nodes. One of the things we heard from customers is, great, you start at 3. For my branch office, I need really 2 nodes. I need to scale this down and start small in a 2-node hyperconverged. So we announced a 2-node hyperconverged configuration And this is something we are pretty proud of, which lets you really use Spaces Direct at an entry-level branch office configuration, and we can scale up all the way. So another thing we have done, just to kind of shift gears a bit, diagnosing storage is hard. We know things will fail. Disks will fail, controllers will fail, the SAS expander will fail. When you're trying to upgrade the firmware of a hard drive, things will fail. So we wanted to make sure we gave a solid health service that can be used by you very simply, where we are not aggregating and showing you 10,000 metrics, rather showing you the filtered data on really what's wrong and what's right, okay? So that you really get prescriptive action on root causing and can go and replace a drive in a very automated fashion, okay? This is something we learned a lot from our cloud platform system, which uses Spaces, storage Spaces, and we have incorporated this here. So what does it do, right? I'm not going to go into each. It monitors a bunch of things. It looks at your volume level stuff, at your element management of your drives. It does a bunch of things. And by the way, the health service can be exposed in many ways. We have a SCOM MOM pack. It can be done in PowerShell, and it can be done by a RESTful interface as well. So I'm just showing you the MOM pack extensions of a system called Nebula we use internally, where it shows the state of the system. So at any point, you know where exactly your storage system state is. So with that, one of the cool things I'm going to show you, just shifting gears a bit, how can we extract the performance, the maximum performance from storage Spaces Direct, okay? So I'm kind of proud to show you this quick demo with our partners, Intel. Intel basically took 4 systems, Supermicro systems, and the interconnect was 40 gig Chelsio iWarp RDMA adapters. And each of these nodes has basically got a capacity tier and a cache tier, okay? So thanks to Intel, for giving us the demo, and here you go. So we are showing you 4 nodes here. 4 nodes each of them have a disk, obviously. These are Intel NVMe SSDs. And then if you show, we use a benchmark called disk speed. It'll show you each of those nodes pushing around 770,000 IOPS. Okay, so 4 nodes gives you upwards of 3 million IOPS. All of this on 4 standard servers, okay? So we have indeed pushed the limits far. I do want to make sure we feel proud about the performance. We feel in the industry we have the best in class industry-leading performance. And that's not all. I think if some of you visited the demo yesterday in the keynote, we pushed upwards of around more than 6 million IOPS on a 16-node hyperconverged cluster, okay? So I talked a bunch about hyperconverged, but you also have converged, which is our converged or disaggregated, where you can separate storage and compute. So what we are saying as quick shout out is if you have a small deployment, start with hyperconverged, but if you have a larger scale deployment, we believe that at some point, separating compute and storage gives you the best benefits because it lets you do really fine-grained expansion of each of the layers, okay, compute and storage. I talked about storage Spaces Direct. Let me do a quick shout out to another feature called Storage Replica. One of the things we heard from customers is, hey, I spent a lot in replication. Give me something that can work with any volume, not just Spaces, but any SAN volume as well, okay? So we did Storage Replica for DR. Now, this basically has flexibility. It does synchronous or asynchronous replication, can work with any volume, your existing SAN volume, or also with Spaces Direct or Storage Spaces. It has integrated deployment modes where you can do either a metro cluster or even a stretch cluster, basically, depending on your needs. It basically gives you low-cost DR. NetPile is going to be talking about this in his session. I think he has had a tremendous amount of sign-ups. So if you're interested here, go and take a look at that session. Another thing we did was storage quality of service. One of the things we heard from our service provider friends was, hey, I don't want a couple of VMs to monetize the bandwidth in my data center. Give me something to make sure certain VMs, groups of VMs, or one VM, or even a VHD, I can put maxes and mins in terms of IOPS, where I can say that, hey, for this VM, like my SQL log VHD or my SQL VM can get this much IOPS maximum, this much minimum. So we did something called data center storage quality of service, which is basically across the data center. You can set this mins and maxes. It also becomes an upsell feature for many of our platinum partners, where you can upsell platinum, bronze, gold VM capabilities. So we talked about software-defined storage, but also, I just want to make sure we embrace all the different storage portfolios. The first two is hyperconverged. I talked about SAN alternative with spaces shared, but we also work very well with our existing SAN partners around, with Windows Server 16. All the features that you have, trim and ODX, all the SAN capabilities continue. And we also work with our NAS friends as well. So we have a lot of support for different kinds of storage. I'm not going to go into this slide. This gives you a quick overview of what are the different things we have done in software-defined storage. I'll leave it out, take a picture. We have many sessions. But the one I would recommend for this one here is Klaus Jorgensen and Netpile are going to be talking about the whole software-defined storage strategy and portfolio in a session. I believe it's tomorrow. So go and take a look. So now let me switch gears a bit. So we talked about storage, compute, and network. Everything is in software, right? So we all know as an industry, it's really crucial to make sure that we put this all together, okay? Now, we wanted to make sure that the experiences of deploying this, integrating this, testing this at scale, we do a good job and not just give you a bag of bits where you go and learn the experiences once again and repeat some of the mistakes that we have done, okay? We didn't want you to do that. So what we are doing is really working with our partners on this program we call Windows Server Software Defined. And what it's really doing is we work with our partners on a multi-stage process. The first couple of stages in the program, we work with them on designing the configurations. This is software-defined compute network and all storage altogether. And we also have them validate the offers with us. Okay, we really have a close partnership. Then on the deploy stage, the partner goes out to your site as a customer, goes out and helps you deploy so that your day zero experience for deploying hyperconvergence, the software-defined data center, is really smooth. And then the operate piece is day 100 with System Center, you are operating at the right level and have the right best practices guidance from Microsoft and the partner. So who are the partners? A quick shout out to our partner friends. We are really proud and happy to have our 12 partners all across the industry. I'm not going to name everybody here. They're all in alphabetical order. They have their own booths. First of all, before I go to the booths, they have more than one offer. I just kind of picked one offer from each partner just to showcase you this is real. All these partner systems are running software-defined data center. They are validating it with us. We are working very closely with them. So this gives you choice. With your favorite partner, go and pick your favorite partner, work with them, go to their booth. We have this Windows Server software-defined booth where we have a partner showcase. And then each partner also has their offer in their private area as well. All right. So we wouldn't be here without your support. And as Matthew mentioned, we have been testing Windows Server since October 2014 when we released the first preview of Windows Server, TP1. And then we have been giving TP2, TP3, TP4, TP5, and then now we are going GA. This is very different from the traditional earlier Windows Server operating systems where we have gone quiet for a long period of time and given you a whole lot suddenly and not having given you a chance for feedback. So here's some of our customers. Again, some, okay? There's a lot more customers who have worked with us. What are they saying about us, right? So shielded VMs. This is something we didn't talk about here today. I believe there's a session here from Dean Wells. Shielded VMs, awesome, very useful from Rackspace, Jake Morrison. Ravi talked about SDN. SDN is a huge cost saver for some of our customers, right? A quote here from Chris from Convergent Computing. Storage space is direct. Also another big cost saver, okay? This was Rand we work with, he looked at, the storage in the enterprise, and he was really able to reduce costs substantially. Clustering. Clustering is no longer, this complex technology. It's easy to deploy from Daniel. And then Nano Server, right? Pretty fast. Nano is small and fast. And lastly, frictionless rolling cluster upgrades. It has been very useful, as Matthew pointed out, for enabling you as a customer to seamlessly move from 2012 R2 to 2016. With this, I'm just going to do a quick recap. What did we see today? So Azure inspired Server 16, software-defined data center. You have compute, network, and storage, a lot of rich features, very cost-effective, flexible, reliable, bring a lot of the resiliency principles from Azure, leading price performance. I showed you 3 million IOPS, 6 million IOPS, agile, as Ravi mentioned, everything managed by System Center, and lastly, all validated on partner hardware, okay? And then straddling this all is basically the security with shielded VMs and a bunch of other things. So overall, we feel we are trying to give you a package in our software-defined data center story along with our hardware partners. So with that, I'm going to wrap up the session here and leave a little time for questions. Here is a quick pointer to some of the sessions coming up in compute, networking, storage, and also a shout out to some of the management and hardware sessions here. So with that, again, thank you very much for your time. If there's any questions, we'll be here in the podium. Thank you.